seen the addition of complex number. Now we will see some example of addition of complex number. Suppose you have Z1 as 3 plus 2i and Z2 as 5 plus 10i. So we can add Z1 plus Z2 as 3 plus 2i plus 5 plus 10i, right? So 3 plus 5, we will add a real part with real part. 3 plus 5, 10i common, 2 plus 10. So it will be 8 plus 12i. So the Z1 plus Z2 will be 8 plus 12i. Now we will see some properties of addition of a complex number, which are very important, can come in your exam, like define 3 properties of addition of complex number or verify any one property like that. So the properties of complex number, right? So the first property is a commutative property. So let Z1, Z2, Z3 are complex number, 3 complex number, right? So the first property is Z1 plus Z2 will be same as Z2 plus Z1. And this property is called commutative property. This property is called commutative property. Right? So, in natural number, 2 plus 3 is equals to what? 5. Right? And 3 plus 2, it is also 5. So, now in natural number, the commutative property holds for addition. So, similarly, in complex number as well, commutative property hold for addition. Means Z1 plus Z2 will be equals to Z1 plus Z2 plus Z1. You can verify this property by taking example like this. Suppose Z1 is equals to 3 plus 2i and the Z2 is equals to 8 plus 39. So what will be Z1 plus Z2? This will be your LHS. Left hand side will be Z1 plus Z2. So addition of Z1 plus Z2 will be 3 plus 2i plus 8 plus 39. That means 3 plus 8 plus 2 plus 3 of I. I am taking I common. 2 plus 3, 3 plus 8. So this will be 11 plus 5i. Right? Now we will take LHS, RHS, which is equals to Z2 plus Z1. So what is Z2? It is 8 plus 39. And what is Z1? 3 plus 2i. Right? So 8 plus 3 will be 11. Taking I common, 13 plus 2 will be, just 1 minute, 8 plus 39 and 3 plus 2i. And here we have written 3 plus 2i and 8 plus 39. So 3 plus 8 and 2 plus 13, not 3. I am so sorry. 2 plus 13, so it will be 15. Now here 8 plus 3 will be 11 and 13 plus 2 will be 15. You can see both LHS and RHS having the same answer. 11 plus 59, 11 plus 59. So commutative property holds in a complex number. Now the second property is associative property. Associative property means you have studied like this. 2 plus 3 So you can also verify this property by taking some example. So let's take Z1 as 2 plus 3i, Z2 as 7 plus 2i, and Z3 as 5 minus, or you can take plus I. Okay, so first we will start with LHS. LHS is equals to Z1 plus Z2 plus Z3. That means you have to apply addition in this bracket first, right? So Z1 as it is, Z2 will be 7 plus 2i plus 5 plus I. So Z1 as it is, I am not putting value of Z1 here. Now Z7 plus 5 will be 12 plus 2 plus here 1, right? So it is 3i. Now what is the value of Z1? It is 2 plus 3i, a plus 12 plus 3i. So 2 plus 12 will be 14. 3 plus 3 will be 6i. So call this as equation 1. This is your LHS. Now we will find RHS. Now for RHS, consider Z1 plus Z2 plus Z3. That means first we will do addition in this bracket and then for the third one. So what is first number? It is 2 plus 3i plus, what is second number? 7 plus 2i plus Z3 and it is. Now 2 plus 7 is 9 plus 3 plus 2 is 5i plus what is Z3? It is 5 plus I. Now 9 plus 5 means it is 14 and 5 plus 1 is 6i. So this is your RHS. So from equation 1 and 2, your LHS is equals to RHS. I hope this property is clear. Now the third property, that means associative. The complex number, addition of complex number is associative. Now the next property is identity property. Next property is identity property. See, we have similar type of properties in natural or integer as well. Like 0 plus 2 is equals to what? 2. 2 plus 0 is equals to what? 2. That means if you add any number to 0, it will give you the same number. So similar property for your complex number. Z plus 0 will be Z only. If you add 0 to any complex number, it will give you that number. And this number is nothing but your identity. This property is nothing but identity. Like suppose Z1 is 2 plus 3i. Okay? And 0 is nothing but 0 plus 0i. Complex form. So the Z1 plus 0 means 2 plus 3i plus 0 plus 0i. 2 plus 0 is 2. 3 plus 0 is 3i. We are taking I common. So this is nothing but your Z1. So this is identity property. Now the next property, which is very important property, which is complex number together with its conjugate will give you 2 times real part of Z. 2 times real part of Z. This is very important property. Means if you add complex number and its conjugate, you will get 2 times the real number. Means imaginary part will eliminate. Okay, so we will see this by taking example. Suppose Z as 2 plus 3i. Okay, then what will be its conjugate? Conjugate will be 2 minus 3i. Now what we have to do? We have to take its addition. So your LHS is Z plus Z bar, which is equals to 2 plus 3i plus 2 minus 3i. Yes. So here 2 plus 2 is 4 plus, take I common, 3, and here it is minus 3, right? So 4 plus I of 0. So this will be 4 only. But we can write 4. See, what is the real part here? 2, right? The real part is, this is real part of z. So 4 can be written as 2 times of 2, which is equal to 2 times, since 2 is nothing but what? Real part of z. So you can take any example to verify this property. So this is very important property. Z plus z conjugate is equal to 2 times real part of z. And the last property is, the last property, that is the property number 5. It was property number 4. Z plus Z1 plus Z2 whole conjugate is equals to Z1 conjugate plus Z2 conjugate. That means you can separate the conjugate over the addition. We will also verify this property by taking some example. Suppose Z is equals to 7 plus 3i and Z2 is equals to 5 plus 2i. So what is your LHS? LHS is Z1 plus Z2 whole power. So first we will require Z1 plus Z2. So first we will calculate Z1 plus Z2. 7 plus 5, 12. Taking I common, 3 plus 2, 5. And what will be Z1 plus Z2 whole conjugate? इसका conjugate क्या होगा? 12 minus 5i. Right? Similarly, we require separate conjugate Z1 and Z2. So what will be Z1 bar? Z1 ये है तो इसका conjugate 7 minus 3i. What will be Z2 conjugate? 5 minus 2i. Okay? Now consider LHS, which is Z1 plus Z2 whole bar. Just now we have find out its value. So this is 12 minus 5i. And what is the RHS? Z1 bar, Z2 bar. What is your Z1 bar? 7 minus 3i plus, what is your Z2 bar? 5 minus 2i. Now find out its addition. 7 plus 5, 12. Taking minus common. 3 minus 3 minus 2 will be minus 5i. So this is your RHS. So from here and from here, your RHS is equals to your LHS. So this property also holds. So these all are 5 properties of addition of a complex number. Now the next operation algebra is, the next algebra is a scalar multiplication. Next. So this was the second algebra, that is addition. Now we will see the next algebra, that is the scalar multiplication. Multiplication is different and scalar multiplication is different. Scalar multiplication means we are multiplying that complex number with particular scalar. Scalar means any scalar, like any real number. 2, 5, minus 1, anything. Okay? So let k be any real number. K belongs to real number and z is your complex number, which is equals to a plus ib. Then a scalar multiplication k into z is defined as k into a plus ib. So you have to multiply k with each term, real term and imaginary term. This is k times a plus I, k times b. Okay? So this is your scalar multiplication. Like I am giving you one example. Example is, if z is equals to 7 plus 3i and k is equals to 5, okay, so the multiplication imaginary and the real part. Also, suppose z1 is equals to 2 plus 3i and the z2 is equals to, if I give you another example, z1 has 2 plus 3i and z2 is 5 minus 3i, or take 5 plus 3i. Okay, so can you find 5z1 plus 2z2? That means we have to do addition as well as the scalar multiplication. First we have to find scalar multiplication 5z1 and then 2z2 and then we have to add this. So we can do it in one step only. So 5 times z1 means 2 plus 3i and plus 2 times z2 means 5 plus 3i. Now first we will multiply the numbers. What we will do is scalar multiplication. So 5 into 2 is 10 plus 15i here, and here it is 10 plus 6i. Now we can add 10 plus 10, 20. Taking I common, 15 plus 6, 21. So this is your answer. Now the next term, you can also say 0 of z is equals to 0 times a plus I 0 times b, if you have z as a plus ib. Okay, so this is a very simple operation, that is a scalar multiplication. Now we have another algebra, that is a subtraction of a complex number. It is a kind of addition only. It is a kind of addition only. So the third algebra is subtraction. It is fourth algebra, not fourth. Subtraction of complex number. Okay. So for subtraction, suppose you have z1 as a plus ib and z2 as c plus id. So z1 minus z2 can be written as z1 plus minus of 1 times z2. I am taking minus side inside. Okay, so this become now scalar multiplication. Now this is equals to a plus ib plus minus of 1 into c plus id. Now this is a plus ib as it is, plus taking scalar multiplication minus c minus I d. Now here it is a plus minus c. So a minus c plus taking I common b minus d. So in short, like addition, like in addition we do the addition of real part and imaginary parts. In similar manner you have to do subtraction of these two real part and imaginary part. Same like the addition only. For example, z is equals to suppose 10 plus 2i and z1 is equals to 5 minus plus 7i. So what will be z minus z1? It will be 10 plus 2i minus 5 plus 7i. So this will be 10 minus 5 plus taking I common 2 minus 7i. 2 minus 7. So this will be 5 plus I of 2 minus 5, 7 will be minus 5. So answer will be 5 minus of 5. I am taking minus out. I hope the subtraction is clear. Now we will see properties of subtraction. See, commutative and associative property does not hold for the subtraction. Like in real number also, 2 minus 3 is not equals to 3 minus 2, right? Here it is minus 1 and here it is 1. The sign is different. So the associative property and commutative property does not hold for subtraction of a complex number. So the properties of subtraction. Subtraction of complex number. So the first property is what will be Z bar? It is A minus IB. Now Z minus of Z bar. It will be A plus IB minus A minus of IB. So this will be A plus IB. Now take minus inside. Or you can directly do subtraction A minus of minus A. A minus A plus taking I common B minus and this minus will plus B. Right? So here this will be 0 plus I and here it is 2B. So this is nothing but 2IB, which is now here in this what is the imaginary part? It is B. But here we are getting 2. So this is nothing but 2 times imaginary part of Z. Okay? So Z minus of Z bar is 2 times imaginary part of Z. The next property is Z1 minus of Z2 whole conjugate is equals to Z1 conjugate minus Z2 conjugate. Like in addition, we can separate conjugate over addition as well as over subtraction. So we will also verify this property by taking example. So for example, let Z1 as A plus IB and Z2 as C plus ID. Okay. Now we will require what we will require Z1 minus Z2, Z1 minus Z2 whole conjugate, Z1 conjugate and Z2 conjugate. So what is Z1 conjugate? A minus IB, Z2 conjugate, C minus ID. Also we require Z1 minus Z2. So Z1 minus Z2 will be A minus C plus B minus D. And what will be its conjugate? So Z1 minus Z2 whole conjugate will be A minus C as it is minus I B minus D. Okay. So what is your LHS? LHS is Z1 minus Z2 whole conjugate, which is equals to this A minus C minus I common B minus D. Call this as equation number 1. Now what is your RHS? RHS is Z1 minus Z2. Z1 conjugate minus Z2 conjugate. So what is Z1 conjugate? It is A minus IB. And minus what is Z2 conjugate? C minus ID. But we always want, after doing operation, we want that number should be in a complex form. So we will convert this into a complex form by taking I common. Okay, so here real part with real part. So A minus C. Okay, taking I common. Here I minus I minus I. So we will left with B, this minus sign and with B. So this is your RHS. So from equation number 1 and from equation number 2, you can see both are equal. You can take any example, 2 plus 3i, 5 plus i10, like that, and you can verify this property for subtraction. Okay, this is homework for you. I am taking some real example and I am showing you this property, so that will be quite easy to understand. So let Z1 as 3 plus 7i and Z2 as 5 plus 2i. You can take minus also, minus 2i plus, instead of plus you can take minus sign as well. So what will be Z1 bar conjugate will be 3 minus 7i. What will be Z2 bar? It will be 5 minus 2i. Okay. Now what will be Z1 minus Z2? Z1 minus Z2, 3 minus 5 will be 3 minus 5 plus I times 7 minus 2. So this is minus of 2 plus 5i. Okay. Now we require conjugate of this. What is your LHS? Your LHS is Z1 minus Z2 whole conjugate. So LHS is Z1 minus Z2 whole conjugate, means we have to take conjugate of this. So this is conjugate of this will be minus 2 only. This sign will change and it will be I. Don't change sign of real part. You have to just change sign of imaginary part. Okay. So this is minus 2 minus 5i. Now RHS. RHS will be Z1 bar minus Z2 bar. So what is head 1 bar? It is 3 minus 7r. Minus, what is head 2 bar? 5 minus 2r. So we will do subtraction. 3 minus of 5 minus this minus, okay? And here taking I common. So 7, this 7 minus of minus plus, just 1 minute. It is minus of 2. Because here we have minus sign as well, right? So this is minus 7 minus minus plus 2. Okay, so here 3 minus 5, it will be minus 2. Minus 7 minus 2 will be 5r. So you can compare these two answers. So this is your RHS. So from LHS and from RHS, you can see both are equal. Okay. So in exam, the question can come, verify this property, or it can become like this: state any one property of subtraction of complex number and also verify it. So okay, so it can come for 2 or 3 marks. I hope till here the operations, that means the algebra, are clear. The first algebra was equality of a complex number, second was addition of a complex number, third was a scalar multiplication, a fourth was a subtraction of complex number. Then the next will be a multiplication of a complex number. Next is a multiplication of a complex number, that we will see in next class. Till then, just go through these properties. Okay, take some another examples and try to verify these properties for that examples, so you will get used to it. So there is one homework for you. It is on page number 6, exercise 1.1, problem number 2. Write the conjugate of the following complex numbers. So you have to just write down all the conjugate. There are 7 to 8 complex number given to you, so you have to write down its conjugate. Okay, the next question is question number 3. Find A and B. If the certain expressions or certain equations are given to you, you have to find out value of A and B. So till now we have completed addition and subtraction. So just do first and second sub question from question number 3. So this is for your homework. Don't do third and fourth problem, that we will see in next class. Hope this session is clear to all of you.